Suppose a ship is sailing 10 knots in the direction of 60 degrees. The current vector is 4 knots, 30 degrees. If the captain wants to maintain the course of 10 knots, 60 degrees, find the adjusted vector. So let's start out by drawing east and a 60 degree vector at 60 knots. Excuse me, a 10 knot vector at 60 degrees. We're going to call that B, vector B, as in the boat. And then the current vector, well, there's east again. Now this is going to be 30 degrees. It's only going to be 4 knots. We're going to call that vector C. So right in here is 30 degrees, and vector C is, vector C is 4 knots. Well, if we want to find the adjusted course, we need to take vector B and add to it the opposite of vector C. So what that is going to look like is, here is due east, here is vector B, and the opposite of vector C. This adjusted vector we are going to call vector X. Vector X is the adjusted course that the captain needs to program in order to maintain the intended course of 10 knots and at 60 degrees. To calculate this, let's go to another page and do some of the math. So vector B has a horizontal component of 10 times the cosine of 60 degrees. It has a vertical component of 10 times the sine of 60 degrees. The current vector has a horizontal component of 4 times the cosine of 60 degrees and a vertical component of 4 times the sine of 60 degrees. 30 degrees for the current. Well, we want to take the opposite of B, take vector B and add to it the opposite of the current. Therefore, adding the opposite, subtracting, our vector X has the horizontal component of 10 cosine 60 degrees plus the opposite of, or minus 4 cosine 30 degrees. Doing the math on that, we end up with 1.5 knots. And the vertical component of x is going to be 10 sine 60 plus the opposite of, or minus 4 sine of 30 degrees, which comes out to be 6.6 knots. Let's add a page to this. So now we're going to do the math using the value of 1.5 knots for the horizontal component and 6.6 knots for the vertical component. But before that, let's draw a quick picture. There's east, there is B, there is the opposite of vector C, and I need to do this all over. A little more room here. There's east, there's vector B, here's the opposite of vector C, and this is vector X. We want to find its magnitude and its direction. Well, X has a horizontal component and a vertical component. The horizontal component we said was 1.5 knots, and the vertical component 6.6 knots. Therefore, the magnitude is just your Pythagorean theorem, which is the square root of 1.5 squared plus 6.6 squared, which comes out to be about 6.8 knots. And the direction that's this angle right in here is the inverse tangent of opposite over hypotenuse. So that's 6.6 over 1.5, which comes out to be 76.9 degrees. Therefore, X, vector X, has a magnitude of 6.8 knots and a direction of 76.9 degrees.